Welcome to Mathlet 101. I'm Mr. van der Merwe, still the best, and we're going to be doing data handling today. This is only going to be part one of your data handling needs to be collected, and that's all going to start at the green point, green for go. So you are going to first have a question. What am I going to collect my data on? What is the question that I want the information for? Then, going over to yellow, we are going to be collecting the data. So that's when you are doing it in multiple ways, collecting it. After that, we're moving over to organizing it in orange. Once I've organized all of the data, now I can start analyzing it in red. So now I'm standing still to analyze what's going on. And once I'm done with that, I'm going over to purple, where I can actually interpret the data to know whether the question is answered or not. Let's move through the data handling process and let's start with the question. There's just one golden rule with the question that you need to follow. And that is the question that you have, it needs to describe what you want to find the conclusion for. For example, how many cars drives past a certain robot at a certain time. I'm clearly describing about where I want to have the data. That is what my question is. I want to know how many. Once I've asked my question, I can start by collecting the data. Now you can collect your data from two places, which is actually one, but you will understand once I'm done here. First of all, you have your population. Now, your population is what we refer to as all the objects that belonging to a specific set. So everybody that can contribute to your data will fall in the population. It is important to note that this is the broader group, the population. For example, I'm looking at the newborn babies that's in South Africa, the whole of South Africa. But then we can go a little bit smaller than the population, where we're just looking at a sample. Now the sample comes out of the population. So the population is everybody that could give an answer, and the sample is the only ones that did give us the answer. With regards to the sample, it's very important that it needs to be a random selection to keep your answers as unbiased as possible. Everybody needs to have a fair chance to be chosen, and it should include all races, all genders, all objects, different types of cool drinks. Everything needs to be accommodated for. Then, once you've chosen that, we will then have our sample. So if we knew that the population that we were looking of for the babies was the babies born in South Africa, the sample then would be the babies that are born in Wilgers Hospital at a specific point, because I want to base on the condition of the Wilgers Hospital. So I'm only looking at the Wilgers Hospital babies. That will then be my sample. Next up, we need to be able to collect the data as mentioned. Now we need to look at the different methods to do it. Now there's a variety. You can look at interviews to do with people, surveys, there's research projects. You can go into historical records with Google, with hard copy documents. You can have observations and a lot of other possibilities that you can continue on with. These are all different ways to collect the data. The only important thing when collecting the data, it needs to be, number one, unbiased, and it needs to be able to give you a clear answer. You cannot guide somebody to an answer with a survey or an interview, but all the possible answers need to be able to be given. You can't just say, what is your favorite color? Red, blue, or nothing. There is a variety of colors, so you can't limit the choices. Same with observations. You can't only look at or doing an observation on rugby players when I want to have sport people, so I need to look at all the different types. When we are collecting this data, we can categorize the data into two groups. You get your quantitative group, so for the quantitative data, and you get your qualitative data. Basically, our quantitative data, this is your numerical data. So this is where numbers are involved. And there's two types. First one being discrete, and the second one being continuous data. Your discrete data means we are looking at whole numbers. There's two people. You can't have 2.5 people. So we're only looking at 2 or 3 or 4. It's whole numbers that we're referring to. Continuous data is at any stage you can have that measurement. So you are allowed to have decimal places. How long are you? What's your length? 1,96. But you can have someone else that's 1,961. And you can have someone else that's 1,9615. At any stage you can measure a value. Hence it is the continuous data. Then you get your qualitative data. The qualitative data is a lot more descriptive. What is your favorite color? That would be an example of describing descriptive data. Your descriptive data also involves your senses. So anything that you can see, feel, hear, etc., that will be your qualitative data. What's your favorite music? Something that you hear. What's your favorite color? Something that you see, and so forth. With your tables, you get three different types of tables. You get your tally table. This is the basic one, where you simply make ticks. How many blue cars passed me? 1, 2, 3, 4, 5, etc. You literally make ticks for every blue car that passed you. Or you can get a frequency table. Now, frequency table is, instead of using ticks, you use numbers. There was 5 cars or 7 red cars, and so forth. And then the last one we have is the cumulative frequency table. Now, the cumulative frequency table gives you the accumulated amount that you are looking at, not just for a specific interval or specific item, but in total. As we progress, how much did I have in total? If we look at the table that I gave here, you will see for the hours spent playing, how many kids play between 0 and 1 hour. The frequency is given as a number 2. So how many people plays at this stage? 2. If I look at the 1 to 2 hours that learners are playing, there's 5 kids. So how many kids in total are playing less than 2 hours? So this is the total group. It's now the 7. If you see in green, so this is the number of people who play for 2 hours or less. Similarly, if we look at the purple arrow, for the 17, we got that by saying how many learners play less than 3 hours. We had 7 playing less than 2 hours. So plus the additional 10 for the 2 to 3 hours, so I have a total of 17 now. That is my cumulative frequency. It's important to note that once you're at the end, you need to get the total amount of learners that was surveyed or cars that was observed or whatever the data was being involved with. That total needs to be at the end of the cumulative frequency. Second way we can organize our data is with graphs. Now we get a variety of graphs. Your line graphs, your bar graphs, your histograms, your pie charts, and you get your double graphs. And the double graphs includes your stacked graphs as well. We will be looking at these graphs now, just to summarize what's the important points to know when you are writing or drawing a graph. First of all, we're going to be looking at the line graph. For your line graph, it's important to have your headings. You have to have a main heading, the cookie cells. You have to have your y-axis heading, number of boxes, and you need to have your x-axis heading, the days, where I'm going even further and saying this is Monday, Tuesday, Wednesday, Thursday, and Friday. So your heading is very important. Then you need to have equal intervals, 1, 2, 3, 4, 5, 6, 7. They all need to be equal intervals. Otherwise, your graph will be skewed. We also need to know that certain times we can have a dotted line versus a solid line. As you remember from the previous slides, we referred to the continuous data and we also got the discrete data. Whenever your information is discrete data, meaning you cannot have decimal places, 1 person, 2 people, 3 people, then you need to have a dotted line because it is discrete data. You can't measure it at any given stage. If I'm referring to the length or the cookie cells, I can sell 1.5 box. That's an entrepreneurial skill. Then we will have a solid line, which will represent my continuous data. Also, whenever you're drawing your graphs, make sure that it is big enough, at least half a page. And you need to be very accurate. Going up from the x-axis, on Monday, only 1 box was sold. So I'm going up on the x-axis on Monday, going on the side for the y-axis on the 1, And wherever the X and the Y axis cut each other, that's where I plot my point. Make sure it's very accurate. For bar graph, once again, the heading is very important. You need to have your titles, you need to have your labels, you need to have the equal intervals, you need to have your spaces between bars. This is very important. From the y-axis to the first bar, there's a space, and then between all of the bars, there is spaces as well. Then we need to make sure that it is big enough once again, and we need to be working very accurately. Histogram. We will see that it's almost the same. We still have the importance of our headings. We're still going to have our equal intervals, but we're going to have no spaces in between. As you can see from the example, there is absolutely no spaces between the bars that's on the histogram. Do not get confused. There was no president between 0 and 42 that was a president. They were always older than 42, hence that's nobody there. It's not a gap that is existing, it's just nobody was there, so we're at 0. So your histogram will start at the y-axis, moving on with no spaces. Once again, it needs to be big enough and it needs to be accurate. The fun one that we are going to be discussing now is the pie chart. Our pie chart also has certain rules that you need to follow to get your marks. Once again, you have to have your headings, you have to have your keys. Because with a pie chart, we need to indicate which sector is which. Now, there's different ways that you can actually apply your key. Either you can, as done in the example, in the color of the sector, we write sci-fi, there was only 4. For comedy, 4. Action, 5. I'm clearly giving the information so that it's available and so that we can understand how many there was. If you do not want to write it on the side of the sector or even inside the sector, you can have on the side of the chart, you can have a table indicating which colors is equal to which data or which symbols is equal to which data, so that you have your key on the side as well. Once again, we need to be working very accuracy. And for a pie chart to be accurate, you need to have the correct apparatus. You need to have your protractor, you need to have your compass, and everything that is required, your rulers, your pencils, whatever the case might be. It's also important to do the calculations correctly, but we will get to that shortly. As mentioned, you need to have as much information as possible. Give the total that there is per sector as well as the percentage of how many the comedy accommodates towards the entire data set. As mentioned, I said we're going to be doing the calculations. Now the calculations I'm referring to is how to get the size of the sector. So whenever you're drawing your pie chart, you need to be able to have it the correct amount of degrees. And that you do by following the formula. You simply take your favorable outcome over all the possible outcomes and you multiply it by 360 degrees. For example, if we look at the graph, the drama, there was only 1. So my favorable outcome for drama is 1 over, now we add up all of the data, which will give me a total of 20. So 1 out of 20 times 360 will then give you the amount of degrees that my drama sector needs. The last one that we're doing is our double graphs. Now the double graphs can be with line graphs or it can be with your bar graphs, but the important thing is we are having more than one set of data that's being used. So we've got product A, B, C and D for strategy 1. So they are clumped together. Then I've got my space. Now I'm clumping them again together for my double bar graphs and so forth. If you do not want to write them next to one another, you can make use of a stacked graph where we're putting them on top of one another. So we've got product A, which was 50 plus or 100 plus the 100 of product B plus the 150 of product C plus the 70 of product D. So I'm adding them all on top of one another for strategy 1. Same for strategy 2 and 3 and 4 and so forth. That's it for part 1 of data handling. Part 2 will be uploaded as well, and if you have any questions, as always, feel free to ask.